Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about forward selection method. What exactly is forward selection? When do we use forward selection? And what are some of the advantages of using forward selection method? Even before talking about what exactly is the forward selection method, may I request you to subscribe to my channel, also like and share my videos. Let's begin by asking a simple question. What exactly do we mean by forward selection method? Forward selection is a stepwise variable selection procedure in which the variables are sequentially entered into the model. The first variable considered for entry into the equation is the one with the largest positive or negative correlation with the dependent variable. This variable is entered into the equation only if it satisfies the criteria for entry. If the first variable is entered, the independent variable not in the equation that has the largest partial correlation is considered next. The procedure stops when there are no variables that meet the entry criteria. With this background about forward selection method, let's now proceed to see forward selection method in action. I'm going to begin by loading the data set into SPSS. You can see here, this is the file menu. In the file menu, I'm going to go to recently used data. There are 10 recently used files. I'm going to click on the very first option, which is called as the car sales dataset. The moment I click on car sales dataset, the file will be loaded into SPSS. You can see there are important variables like manufacturer, model. We are talking about vehicle characteristics here. So you have the manufacturer of the car, the model of the car, then the variable sales is present. I would like to use sales as a dependent variable. Further, there are other important variables like resale value, type of vehicle, price, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity. Then I have mileage. The goal here is to build a regression model with vehicle characteristics as the independent variable and sales as the dependent variable. How do we build a regression model? Let me first go to the Analyze menu. From the Analyze menu, I'll go to Regression. In the regression option, you have different regression models that you can build. I'm going to choose linear as the option here. Let me click on linear. This will open up a new dialog box, which is called as linear regression dialog box. In the left side, you have all the variables that are present in the data set. In the right side, you have two empty boxes. The first is the dependent list, and the second one, you can specify all the independent variables. Under the dependent list, I'm going to specify sales. And under the independent variables, I'm going to specify different variables like 4-year resale value, vehicle type, price, engine size, horsepower, wheelbase, width, length, curb weight, fuel capacity, fuel efficiency. All of these variables will be pushed into the independent list. As you can clearly see here, there are at least 10 independent variables. Do all these variables contribute in the model building process? I do not know. We have to run a regression model and then find for ourselves whether each of these variables are contributing significantly in the model building process. I'd like to draw your attention to the method. Here, you have what is called as the enter method. If we go ahead and build linear regression model using the enter method. Let me click on OK. This is the output window that you are able to see. You can see here output 3. SPSS prints a lot of output. In the first table, you're able to see variables entered or removed. In the next table, which is very, very important, what you're able to see is the model summary statistics. In this table, you're able to see what is called as capital R, which is the multiple correlation coefficient. What is the value of the multiple correlation coefficient? It is 0.58. Then you have the R squared value, which stands for the coefficient of determination. The coefficient of determination in this case is 0.346, which means 34% of the variation in the dependent variable is explained by the set of independent variables that I have taken. Further, the adjusted R square value is 27%. The next table is a very important table. This is called as the ANOVA table. You can see here the column heading would be the model. Then you have the sum of squares followed by the degrees of freedom, mean square, F ratio, and the significance value. When you look at the row, you have the regression item. You also have the residual. You're able to see a big number for the regression sum of squares. Similarly, you're also able to see a number for residual sum of square. The residual sum of square is 4,27,402. On the other hand, the regression sum of square is 2,26,123. The corresponding degrees of freedom, namely 11 and 105, are also reported. When you take the sum of squares and divide it by the degrees of freedom, you will be able to get the mean square. That is 2,26,123 divided by 11 should give me 20,556. When we look at the residual sum of square, which is 4,27,402 divided by 105, you will be getting the mean square, which is 4,070. When you take the ratio of the mean squares, you will be able to get the F statistic. And the significance value is computed for the F statistic. As you can clearly see here, the significance value is 0.000, which is clearly less than 0.05. Since it is less than 0.05, we can reject the null hypothesis and conclude that the R squared is significant here. Next, we come to the coefficients table. In the coefficients table, you have all the variables, the independent variables that we had entered in the regression model. You have at least 11 different variables like the 4-year resale value, vehicle type, price, engine size, and horsepower. Next, you have the unstandardized coefficients and the standard error. The third column here would be the standardized coefficients or the beta column. This is mostly used for comparison of the independent variables. Further, you have the T statistic, which is computed, and the last column here is the significance value. How do we interpret the unstandardized coefficients? Let's take the example of engine size, which is plus 34.118. This simply means that if the independent variable goes up by 1 unit, that is, if the engine size of the vehicle increases by 1 unit, the sales will go up by 34 units. Similarly, when you look at curb weight, the value is minus 85. How do we interpret the coefficient for curb weight? It simply means that if independent variable increases by 1 unit or the curb weight increases by 1 unit, sales will drop down by 85 units. When we look at the significance level, it's a very interesting column here. We compare the significance value or the P value with the level of significance. Each and every number here will be compared with 0.05 because that is the level of significance. If the p-value is less than 0.05, we reject our H naught. On the other hand, if the p-value is bigger than 0.05, we fail to reject the null hypothesis. 0.911, which is clearly greater than 0.05. 0.734, this is the significance for the variable price. Then we look at the significance for horsepower. Next, the significance for width, length, and fuel capacity. Also, may I draw your attention to the significance value for fuel efficiency. There are a lot of values which are greater than 0.05. The moment the significance value or the p-value is greater than 0.05, it means that the null hypothesis fails to get rejected, and we have to conclude that the independent variable is insignificant. That is, these variables, the entire method has built the regression model with insignificant predictors. I repeat, the entire method has built the regression equation with many insignificant predictors. And therefore, this is not really an efficient model as such. Question is, how do we improve upon the performance of the model? How do we arrive at the best subset of predictors? To answer this question, we use a very important variable selection method, which is called as the forward selection method. The forward selection method, as I mentioned earlier in my opening remarks, is a stepwise variable selection procedure. I repeat, this is a stepwise variable selection procedure in which the variables are entered sequentially into the model. Let me explore the forward selection. Let me explore the forward selection method in detail. To perform the forward selection method, let me go back to the data set. I will go to the Analyze menu, navigate to Regression. Here, I'll be choosing the linear option. To open up the dialog box for linear regression. I will not be making any changes as far as the dependent variable is concerned. I'll also not make any changes as far as my independent list is concerned. Let's look at the method of selection. By default, SPSS uses the enter method. I'm going to click on the drop-down menu here. There are different methods for variable selection. If we click on the drop-down menu here, you have a very important method which is called as the stepwise regression method. The next method is the remove method, followed by the backward elimination method. The last method that we have is called as the forward method. Here, the emphasis is on selection. I repeat, the emphasis here is on selection. The forward selection method is often compared and contrasted with the backward elimination method. Let me choose forward selection as the method of variable selection. Further, if you want to modify or change the values for the entry criteria, how do you do that? You can see here, there's a tab which is called as the Options tab. In the Options tab, you're able to see the stepwise method criteria. You can see here, use probability of F, or the second option that we have is the default F value itself. The entry criteria is specified here as 0.05. The removal criteria is 0.10. You can adjust these values depending upon your requirement. In this video, I'm going to keep it at the default setting of 0.05 and 0.10 for entry and removal respectively. If we click on continue and then say OK, you can see here, this is the output of the forward selection method. In the first model, we are building using only one variable, namely wheelbase. In the second step, we are using curb weight. And the third step, SPSS has used vehicle type. After 3 steps, there is no variable which has been selected, which simply means that in 3 steps, the model has identified the best subset of predictors. The best subset of predictors are wheelbase, curb weight, and vehicle type. Let me scroll down. You have the model summary statistic. Here, you have the model, the R value, R squared value, adjusted R square, and standard error of the estimate. In the first step, you can see wheelbase. When we are building a model with only wheelbase, the R square is 16.6%. If we add curb weight as well as wheelbase, we are able to increase the R square from 16% to 24%. Then we have curb weight and vehicle type. When we use the 3 variables, namely wheelbase, curb weight, and vehicle type, the R square jumps to 29%. No further improvement in R square is possible, and therefore the method stops at step 3. The final R square value that you're getting is 29% using the forward selection method. Let me compare this with the earlier model summary statistic. Using the enter method, we had an R square of 34%. Let's now look at the ANOVA table. You have 3 different ANOVA tables that are being reported. The first ANOVA table is for the first regression model that we had built using only wheelbase. The R square is significant. The second model is built using wheelbase and curb weight. When you look at the significance level here, it is 0.000, clearly less than 0.05, and therefore it is significant. The final model that we have built is using 3 predictors, namely wheelbase, curb weight, and vehicle type. And the R square here, as you can see, my apologies, the P value here is 0.000, which is clearly less than 0.05, and hence, based on the ANOVA table, you can see that R square is significant. Let's now proceed to the coefficients table. The coefficients table. The first model is built using only wheelbase. The second one using wheelbase and curb weight. And the third model is built using wheelbase, curb weight, and vehicle type. Now you can take a look at the significance level. The significance level is 0.000 for the first 2 variables, and it is 0.004. Since the significance level is less than 0.05, it means that all of these 3 variables are important. What forward selection method has done is that it has eliminated the unimportant variables. So the final model will be built using only 3 variables, namely wheelbase, curb weight, and vehicle type. You can see here the output of the forward selection method. It is going to give you a table which is called as excluded variables, which mentions all the excluded variables in the 3 iterations that it has done. With this, I have come to the end of today's video. In today's video, we've built 2 models. One is with respect to the enter method, and we compared the results of the enter method with the forward selection method. We spoke about what are some of the important points in forward selection method. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.